So we're going to go back today and review factoring. So if you look at the warm-up that's on page 461, we're not going to do all these, but I just want to talk about them for a second. It says to solve each equation for x. And the key here is that we want to make sure that every single one of these has to equal 0. So before you can put number 1 in Desmos, you would do 2x squared minus 4 equals 8, and you would draw that line like you learned in Algebra 1, and you have to move the 8 to the other side. So now we have 2x squared minus 4 minus 8 equals 0, and you can put that into Desmos and touch the x-intercepts, which would help you solve for x and get you your answers. So we're still looking at x-intercepts, which is why we're going to be doing this thing, reviewing, factoring, but just wanted to put you in the right mindset. So with that, we're going to skip to the next page, and we're actually going to skip page 462, and I'm going to go to 463, the very last problem. It says create, it says that it wants you to create a factor tree to show the prime factorization of these numbers. So the beauty of this is all you got to do is think of two things that make 66. So take a second and pick two numbers that make 66. For me, if I pick two numbers, it'd be 6 and 11. So if you do 6 and 11, 6 is not prime. It has things that make it still. So 6 is made up of 2 times 3, and 11 is prime. So 11 is just 11. So the prime factorization of 66 is 2 times 3 times 11. Now we can do this in our calculator also. So if you're on a calculator page, you're going to press menu, and then you're going to pick number 2, which is number, and then you're going to pick number 3, which is factor. So menu, number, factor, and when you do that, on the screen it's going to say factor, and you'd put 66 in the calculator and press enter. And it's going to tell you exactly this thing, 2 times 3 times 11. So let's, for a second, take the 66. Maybe you didn't do 6 and 11. Maybe you did 2 and 33. Well, the beauty of this is that it doesn't matter what you start with. So 2 is just a 2. But 33 breaks up into a 3 and an 11. And if you look, this 2 times 3 times 11 is the same thing I got here, 2 times 3 times 11. So it doesn't matter what two numbers you pick to start with, it'll still get you the same answer. So let's try 210 without the calculator. So if I was going to do 210, for me the easiest one would be 21 and 10. 21 is 7 and a 3. 10 is a 2 times a 5. And if I look, 7, 3, 2, and 5 are all prime. So my prime factorization order would be 2 times 3 times 5 times 7. And if you use our calculator, you get the exact same answer. So we're going to go to the next page. And I want you to take a quick moment, and I want you to read this top paragraph. If you need to pause me, go ahead and pause and finish reading. But I want to point out the important things. So we decompose things into their factors. We're going to break them apart into smaller pieces. And so what we're going to do is we're going to explore different methods to decompose a polynomial into factors. We're trying to find the x-intercept. So if you remember back, just a quick vocab review, x minus some number a is called a factor. You set the factor equal to 0 to find the zeros. So I would get x equals a, and that's a 0. And then you can use the 0 to write the x-intercept. A comma 0 is the x-intercept. So they're all the same thing, just in different forms. So once you have factored a polynomial, you can use it to identify the zeros, and we're going to use the zeros to sketch the graph. So I'm going to skip this example with Ping and Shalisha for a second. I'm going to go to the next page. Back one page to page 465. Nope, sorry, 464. And we're going to do the problem on the very first page of the lesson that we skipped, which was letter C. So we're going to start underneath the box. The box is about the same problem, but we're going to just do the problem to start. So it says that I need to factor this thing right here. So I have f of x equals 3x to the third plus 12x squared minus 36x. Now the first thing to do is pull the GCF out. Remember, rule number 1 is always the GCF. Well, 3 goes into 3, 3 goes into 12, and 3 goes into 36. So I know I'm going to pull out a 3. This is 3 x's, this is 2 x's, and this is 1 x. So I can at least pull 1 x out of all of them. So I'll put an x over here. Now if I go back, I'm going to divide all of these by a 3, and I'm taking an x away or dividing an x out of all of them also. So now I'm left with f of x equals, when I pull the 3 and the x out, there's an x squared here, plus 12 divided by 3 is 4, and there's 1 x there. Negative 36 divided by 3 is negative 12, and there's no x's left there. And the GCF that I pulled out is 3x. So now what I'm going to do is my GCF is just going to chill, and I'm going to take this thing right here. I'm going to do the box. So I'm going to draw my box. And remember, the first one always goes in the first box, and the last one with the sign goes in the last box. So I have x squared and a negative 12. Then we're going to do our a, which, remember, there's a 1 right here. So 1 times negative 12 makes a negative 12. Ignore the fact that it's negative and list all the factors of 12. So 1 and 12, 2 and 6, 3 and 4, and then you can stop because you'll start repeating at that point. Remember, this is my A, my B, and my C. And B tells the story of my big one. My big one has to be a positive. So these are all going to stay positive. But when I multiply, I need to multiply by a negative. So if these are all positives, then the other ones have to be a negative, because a positive times negative makes a negative. You need to find the pair that when you add them up, make positive 4, the B. Well, this would be an 11. This one is 4, and this one is 1. And I was looking for the 4 pair. So I don't care which one goes in which box, but I'm going to put negative 2 with an X and a 6 with an X. And then you play the what do we have in common game. So these two right here, they both have an X. And the bottom two, side to side, they both have a 2. But remember, because there's a negative on the box I'm touching, this is also a negative. Up and down, these two right here both have an X. And then these two right here both have a 6. And because this one's a positive, this is a positive. There's your other two factors. So now I can rewrite f of x one more time. F of x equals the 3x that I pulled out to start with, my x minus 2, and my x plus 6. If you remember, you take each piece and set them equal to 0. So 3x equals 0. So x equals 0. There's one of my x-intercepts right there. Take the next factor. X minus 2 equals 0. Add the 2 over. X will equal 2. That's another x-intercept at 2. Take the last factor. X plus 6 equals 0. Subtract the 6, so x will equal negative 6. There's my other x-intercept right there. Using what we've learned about cubics, we know this is a cubic, so it should look like this of some sort, and this is positive, so we're going to stay. We don't have to flip-flop or reflect our arms. So I start down below. I have to cross through the dot, cross through the dot, cross through the dot. There's my graph. I did that by factoring. I factored by GCF and then using my box. And then I took every single one of my x-intercepts and put them on the graph right here so that I could sketch a graph of the polynomial. So that's where we're going to stop today, and we'll practice some more tomorrow. And the first problem I actually want to do, a little bit out of order, is I want to do letter B. So in all these problems, it's going to say to factor the polynomial and identify the zeros. Then use the factors to sketch the graph. So the first thing you always do, the first rule of factoring, number 1, is always to pull out the GCF. So what do they have in common? So if I look here at a 2 and an x and a 6 and an x. First look at the numbers. What number do 2 and 6 have in common? Well, they both have a 2 in common. So I can pull a 2 out of both of those. And if you look, I have an x in common also. So really what's happening in my head is the 2 is just a 2. The x squared is an x times an x. 6 is really a 2 times a 3. I'm using that prime factorization that we used on the previous page, times an x. Now if I go down here and see what they have in common, they both have a 2x and a 2x. So I can go down here and pull a 2x out of both. And what I'm left with is an x plus a 3. X plus 3 equals 0. So just by doing the GCF, I am now factored. And remember, you take each factor, each piece, and you set equal to 0. So 2x equals 0. So divide by 2. X equals 0. So one of my x-intercepts is 0. You take the other factor, x plus 3 equals 0. And I'm going to move the 3 over. So x equals negative 3. So here's my other x-intercept. Now you can put this thing right here into Desmos to graph it, or you can use your skills. X squared I know is a parabola. My a equals 2, which is positive, which means it opens up. So if I just was making a sketch, there's my parabola that opens up. Okay, so the next one we're going to do is we're going to go back up here to A that I skipped. A is going to be a little bit more involved, but the first rule does not change. So rule number 1 again, GCF. So you can do the prime factorization if you need to, but this has a 3, this has a 3, and 3 goes into 6. So I'm going to take everything, I'm going to pull out or divide everything by a 3. All of these get divided by a 3. So I'm pulling the 3 out front, and I'm going to be left with some stuff in here. Now before I do anything else, I need you to notice this has an x cubed, which is, look at x 3 times, x squared, and an x. They do all have at least one x that I can pull out of all of them. I'm going to put an x out front. And when I do that, this right here has an x squared left. This was a plus sign. I have an x left. This was a minus sign. And there's a little invisible number here. It's not a 1 though, because remember I divided the 6 by a 2. So to get this number, 6 divided by 3 equals the 2. So this should be a 2 right here. So this is a 2. Now, there's no x, though. I pulled the x out. So this out front is going to stay. This was my GCF. That was what step 1 got me. Step 2 lies in this piece right here, step 2. So before I move on to step 2, make sure you put your A value of a 1 in. Now we're going to draw our box. So this is what I'm going to do for step 2. So step 2, we're factoring the quadratic trinomial, which means my power is 2 and I have 1, 2, 3 terms. So to factor my quadratic trinomial, I'm going to draw a box. The first one always goes in the first box, and the last one goes in the last box. So my 1x squared goes here, my negative 2 goes there. Now I have to make a little tree, so I'm going to do A times C. So A times C equals 1 times negative 2. This is my A, my B, and my C. So that's going to equal negative 2. So factors of negative 2. Well, 2 is 2 and 1. Nothing else makes 2, just 2 and 1. So if you look, B right here is my bigger one. My big one down here should be positive. And because this right here is a negative, then this one has to be a negative, because a positive times a negative makes a negative. And if you check this, 2 plus negative 1 equals my 1. That 1 that I have right here is this 1 that's hiding right there. So the 2 magic things I need for my other boxes are a 2x and a negative 1x. 2x, negative 1x. And now you're going to play the game of what do they have in common. So side to side. So side to side, I'm going to color in purple, then undo it, just so you can see what I'm talking about. So side to side right here. Oh, purple's not working. Let's try red then. So side to side right here. Those two both have a x. Then right here, side to side, these two both have a 2. I'll use blue. These two right here both have an x. And then up and down right here, these two both have, well, they seem to have nothing in common. But the one thing that all numbers have in common is a 1. And then right here, if this is a negative, the box you're touching is a negative, then this is a negative as well. So now you factored it. It factors into the things you've written here. You have an x plus 2 and an x minus 1. Now we cannot forget this right here that we started with, that we pulled out. So when I factor all of this, all of my factors were my 3x out front, my x plus 2 that I got from my box, and my x minus 1. All of those are my factors. A good thing to check is my power that I started with right here was a 3. 1, 2, 3 factors. So remember, you take each factor, set them equal to 0. So 3x equals 0. So when you divide, x is going to equal 0. X plus 2 equals 0. Subtract the 2 over, x equals negative 2. And your last factor, x minus 1 equals 0. Add the 1, x equals 1. So those were my zeros. So if I go to my picture, I have a 0 at 0. I have a 0 at positive 1 and at negative 2. My leading coefficient down here was a positive. So I'm going to start down and end up, just if you think about your cubic function. He does that. And so I start down, and I touch on my x-intercepts, and there's my graph. So letter B, we pulled out a GCF and we were done. letter A. So let's do another one. So we've done A and B. Let's go do C. C should feel very familiar to A. So actually, no, let's just skip C. Let's go to D. So again, rule number 1 is always GCF. So look at those things that you have in letter D. And if you look at 10 and 50 and 60, what do they all have in common? I can divide all by a 10. So I'm going to pull a 10 out front. And this one has no x, so I can't pull an x out. So I pull a 10 out front, I divide everyone by a 10. That leaves me with an x squared. Negative 50 divided by 10 is a negative 5x. And negative 60 divided by 10 is a negative 6. So I'm going to hold on to my 10. This was my step 1. He is my GCF. And I'm going to deal with the rest of this thing. And by deal with it, I'm going to factor by using my box. Now again, the first one goes in the first box and the last one goes in the last box. So this is my x squared and this is my minus 6. Now there is a 1 right here in front of my x. So I'm going to do what's called A times C. 1 times negative 6 is a negative 6. So 1 times negative 6 is a negative 6. I'm not going to look at the negative for a second. I'm just going to write down the factors that make 6. 6 is a 1 and a 6, or a 2 and a 3, and then I stop. Because if I write 3 and 2 here, this pair would be the same as that one. So I don't need that. So I have all of my pairs right there. Okay, so then we're going to go over here. Remember, this is my B value. B tells me the big story. B is negative, so my big ones have to be negative. And if I look, these need to multiply to be a negative, which means the other one needs to be a positive. You're trying to find the pair that adds up to make my negative 5. So if I add these two together, that would make a negative 5. And if I add these together, it's a negative 1. This is not the pair that I want. This is. So in one of them, and by them I mean the boxes, in one box goes a 1x and the other one goes a negative 6x. It does not matter who goes in which box. So right here, side to side, those both have an x in common. And then right here, side to side, those both have a 6 in common. But remember, it's negative. The box I'm touching is negative, so this should be a negative 6. Up and down right here, these both have an x in common. And these two right here, up and down, they seem to have nothing in common, but the thing that all numbers have in common is a 1. And this box is positive, so it should be a positive 1. Here's my two factors plus my GCF. So I factored it, 10, x minus 6, x plus 1. So I take each piece and set equal to 0. Well, 10 never equals 0, so that's nothing. X minus 6 equals 0. Add the 6 over, x equals 6. Over here. And then right here, x plus 1 equals 0. X is going to equal negative 1, which is right here. It's a quadratic because of my x squared, and it's positive. It should open up. So I can draw a little sketch like this. You can also put it in Desmos, but I graphed it using the factors that I found in the x-intercepts. Okay, so now we're going to go backwards just a little.